Okay guys, welcome to lesson number 3 in our ECG series. In the first 2 lessons we talked about some basic pathophysiology of the heart. We talked about the action potential. We talked about measurements and time and how to calculate heart rate, and we identified the basic components of the QRS complex to include the P wave, the QRS complex, the T wave, and we identified what all of those things mean. So just for a brief review, and I'll remind you at the beginning of every one of these videos that I am not an artiste. So as soon as we can come to grips with that and we can all agree upon that, and then our lives will be easier. So here is a QRS complex. Remember, this is the P, and this is the PR interval right here. This is the QRS complex itself. This is the ST segment, and this is the T wave. And then this right here and this right here, remember those represent the isoelectric line where there's no electrical activity. So P wave is the atria. The PR interval essentially equals how is our AV node working. The QRS complex is the ventricular depolarization. The T wave equals ventricular repolarization. Okay, so it's important that we remember these because, like I talked about in the last lesson, this is like learning a new language. And so you'll hear me as we go on talking about the P wave, the PR interval, the QRS complex, and the T wave. So what I want to talk about first in this lesson is how is it that we get this cardiac cycle? Where does it actually come from? How is it that we see it? Okay, so what I'm going to do first is I'm going to draw a picture of a person, and I'm going to do this very much not to scale, although some would argue that this could represent the standard Oklahoman, but we won't go there right now. And I'm not going to put any arms or any legs on this, and I don't want you to read anything into the fact that there are no arms or no legs, but I'm sure there's a joke somewhere like, what do you call a man with no arms and no legs who lays down in front of the door? Of course his name is Matt. So anyway, all that to say this, so in our standard ECG, right now we're talking about single lead ECG, we have a couple of different electrodes, and by way of definition, an electrode is something sticky that conducts electricity, or in this case records electricity. Okay, and it's important to recognize that in some cases the electrode and the lead will be named the same, and other times they will not be named the same. And we'll get more into that nomenclature when we get into 12-lead ECG later in the series. But for now, what I want you to recognize is this. So in the middle of the chest sits the heart, and then we typically have electrodes in these 4 places. Okay, so this is over here on the right arm, this is over here on the left arm, the left leg, and the right leg. Typically, the right leg electrode is a ground for this system and isn't going to really be involved in any of our monitoring of electrical activity. So from now on, we don't really need to talk about it. So what happens then in this situation is the computer will connect the dots with these different electrodes, and we will give them names. We'll call them 1, 2, and 3. But I also want you to kind of recognize that even though we see it as a right triangle on the body, the way the computer sees it is more of an isosceles triangle with the heart sitting in there. So again, 1, 2, and 3. So typically when we are looking at rhythm strips, we're going to look at lead 2 because it's going to have the most direct view over the right atria where our SA node is. Okay, so we're going to be most of the time looking at a lead 2 rhythm strip as we start our single lead interpretation. So what I want to spend the rest of this lesson doing is talking about the most basic atrial rhythm, which is called normal sinus rhythm, and we're going to talk about clues to identifying its presence versus the presence of other things. So as we talked about before, the cardiac cycle is made up of several components, and because you've been reading and studying and you've watched the previous video, you know that those start with the isoelectric line, and then they have a P wave and a QRS complex and then a T wave. And then we carry on here and we have an isoelectric line and we start the process over. And then once again we have our P wave and then our QRS complex and our T wave, and then we just carry on in that manner. And again, my artwork is less than superb, but hopefully you'll get the idea here. So the first thing we want to figure out when we look at these is we want to start looking at the R to R interval, and the R to R interval represents the interval from the peak of one QRS complex to the peak of the next QRS complex. And the R to R interval is important for a couple of reasons. One of the reasons it's important is because this is what we're going to use to calculate rate. So remember I told you before all these different methods to calculate the rate of something. So we would calculate the rate by looking at the number of boxes between here and here, right? So we know from looking at boxes that this rate is going to be somewhere like 300, 150, 100, 75, 60, 50, 40, in the 30s, right? So this is a very slow heart rate. The other reason we want to look at this R to R interval is because we're interested in the concept of regularity. Okay, so what regularity looks like is this. Let's assume for the sake of argument that these lines right here represent QRS complexes. Okay, so you see between these two QRS complexes is 3 big boxes. So if from this QRS complex to the next one is another 3 big boxes, and then another 3 big boxes, and then another 3 big boxes, and so forth, then that would be considered regular. If, however, we didn't have a pattern, we would consider that to be irregular. So let's say, for example, then, I've got a QRS complex here and one 3 boxes away, and then the next one's 2 boxes away, and then maybe the next one is 4 boxes away. Well, this is irregular. Okay, sometimes these rhythms will be grossly irregular, meaning there's no regularity to them at all, or sometimes they'll just be a little bit irregular. And so if something's a little bit irregular, it might look like this. Maybe you've got, of course this is hypothetical, maybe you've got 3 boxes here, and then another 3 boxes, and then maybe this one is just 2 boxes, and then you go back to your 3 boxes, and your 3 boxes, and then maybe 2 boxes. And sometimes we could see a pattern of irregularity that particularly goes with respiratory status, or as we'll learn later, certain dysrhythmias. So it's important then, when we're figuring out is something irregular, is it grossly irregular, or is it just a little bit, slightly irregular? Okay? And sometimes when it's grossly irregular and there's no pattern, then we refer to that as being irregularly irregular. So this one we can see some pattern and it's slightly irregular, but in something that's irregularly irregular, there'd be no way to predict the level of irregularity. So at this point, what I want to show you is an actual ECG rhythm strip, and you can tell that I did not draw this because it's just way too nice and neat. But this does a good job of demonstrating the concepts that we just talked about, and it's going to serve as a nice review. And it's also going to remind me to tell you a couple things I didn't tell you before. So we're going to assume, as I said, that this is a lead to rhythm strip. And one of the things I didn't mention before, which I should mention now, is that in general, if electricity is moving towards the lead, it's going to have an upward deflection on the ECG. And in general, if electricity is moving away from the lead, it's going to have a downward deflection. So we would expect to see our QRS complex predominantly below the isoelectric line. And we'll see examples of that as we go on in the course. But what we see here is you see a nice rhythm, and the first thing I want to do is I want to look at the rate. Okay, and so we decided earlier there's a bunch of different ways to calculate the rate on this, right? We can use the rule where we know that certain boxes represent certain rates, so let's try that. And I'm just going to start right here with this one because it's the center of my attention for whatever reason. So we'll say to here would be 300, 150, 100, and this is 75. So the rate on here is about 75, and if we want to prove that to ourselves, we can count the boxes, and we can say 300 divided by big boxes. So here's a big box, here's a big box, here's a big box, and here's one. So 300 divided by 4 also equals 75 beats per minute. So luckily, because we're all astute clinicians here, we know that 75 beats per minute is A-okay, right? It's right in the middle of where we want it to be, because we know that anything less than 60 is going to be too slow, and we know that anything greater than 100 is going to be too fast. And in general, if something is too slow, we call that Brady, in this case bradycardia. And if something is too fast, we're going to call that tachycardia. Okay, so bradycardia and tachycardia. But this rate is normal, so we're going to give it a very fancy name to represent a normal rate. Are you ready for it? The fancy name is normal. You were expecting something fancy, I'm sure. Something very complicated and smooth. Something probably derived from the Greek, but instead all you get is normal. Okay, I feel very normal right now for telling you about the word normal. So we decided that the rate was normal, and it's 75. The next thing we need to figure out is whether or not our rhythm is regular. Okay, so we're going to ask ourselves the question, is this regular or is this irregular? And remember what I talked to you about before is we can look at this and we can kind of look at the number of boxes in between our R to R complexes. And remember, the R to R complex is the interval between here to here, the R to R interval here to here, and so forth. And by and large, these are all about the same, right? There are 4 boxes in this case. So I would call this regular. Okay, so what we've decided so far then is we have something that's regular and it has a normal rate. So the other thing I want to point out to you is that in this particular case, there's a P wave in front of every QRS complex. And if you have a P wave in front of every QRS complex, that implies that this is an atrial origin. Okay, it's kind of difficult to say for sure that this is coming from the sinus node versus some other part of the atria, but we're going to assume that if it's regular and has a normal rate and it's atrial in origin, we're going to assume that comes from the sinus, and we're going to call this sinus rhythm because we think it comes from the sinus. And remember, I told you the rate was boring, old vanilla ice cream normal. So we're going to call this normal sinus rhythm. Okay, so let's review that real quick then. In order to be a normal sinus rhythm, you have to have a P wave before every QRS. You have to have a QRS complex after every P wave. And then we have to have a normal vanilla rate. And we have to be regular in terms of our rhythm. So this information that we're learning right now in this lesson is going to be the absolute backbone for everything we do from here on out. So anytime you look at one of these rhythms, I want you to look at it and I want you to think to yourself, rate. Is this too fast? Is this too slow? Or is this just about right? Is it normal? Okay, and then I want you to look and say, is it regular? What's the regularity here? Is it regular or is it irregular? And then I want you to ask yourself, is there a P before every QRS and a QRS after every P? And we'll talk about what those mean in our next lesson, but I want you to get in the habit now of looking at this rhythm and figuring out where we think it's coming from. Okay, so if I think something's got a P wave in front of every QRS, then that most likely means this is sinus, particularly if they all look the same. We'll talk about in other lessons how you can get into a situation where the P waves have different morphologies, and morphology means the shape, and so you can have P waves with different shapes that tell you they're coming from different foci or locations within the atria. But for today's lesson, we're just going to focus on the basic, normal, plain Jane vanilla ice cream rhythm called normal sinus rhythm. Now, one of the other things I want you to notice, and we'll spend some more time on this later, is the fact that on this particular example, you'll notice that the QRS complex is relatively narrow. And we identify a narrow QRS complex as one that is less than 120 milliseconds. And you remember from our lesson earlier when we talked about measurements in time that 120 milliseconds would be 3 small boxes. Okay, so 3 small boxes. So if the QRS complex measures from the beginning of the QRS to the end of the QRS and it's less than 3 small boxes, then that's the normal width for the QRS complex. And typically, if we see a QRS complex that is of normal width, that's going to tell us that this is a rhythm that originates above the ventricles. Okay, that's not always going to be the case, but for today's discussion, let's just say that a narrow QRS complex, one that is less than 120 milliseconds, is one that originates above the ventricle. And we call any rhythm that originates above the ventricle as supra, meaning above, ventricular, so supraventricular. And so sinus rhythm, plain Jane vanilla normal sinus rhythm, is an example of a supraventricular rhythm. Okay, so we have P waves telling us that this is coming from the atrium, most likely the sinus node, and we have narrow QRS complexes less than 120 milliseconds telling us this is supraventricular. Okay, gang, I want to take just 1 second to review and then we'll conclude this lesson. So we talked about in this lesson, before you accept after C, review. We talked about in this lesson that in order for something to be a sinus rhythm, we're going to have P waves, and those P waves are going to be in front of the QRS complex. The QRS complex is going to often be narrow, and if it's narrow, that means it's supraventricular. Okay, it's supraventricular. All that means is it's above the ventricle. And then we talked some more about rate. and we talked about using the R to R interval as our measurement of rate. And we can use a number of methods, right? We can use the memorization method of 300, 150, 100, 75, 60, and so on. Or we can use 300 divided by the big box, or 1500 divided by the small box. And then finally, we talked about judging the regularity of a rhythm, also based on this R to R interval, and how regular they come with respect to each other. So, lastly, we decided that for something to bear the name of normal sinus rhythm, which is plain Jane vanilla ice cream sinus rhythm, we have to have a rate that is 60 to 100. We have to be regular. We have to have a P in front of every QRS complex. We have to have a QRS complex after every P. And in general, we're going to have a QRS complex that is less than 120 milliseconds. So as of today, you've officially learned your very first rhythm. You've learned the most common normal rhythm that there is, normal sinus rhythm. In our next lesson, we'll talk about other rhythms that originate in the atria that are cousins of sinus rhythm, and we'll talk about how to differentiate those from one another. As always, if you have any questions, give me a shout.